Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 27 video on the chapter of mensuration, where I will discuss more about how to solve a specific kind of problem, that is how to find the maximum area of grazing by an animal tied with a rope in a certain restricted or unrestricted boundary. These kind of problems are solved by applying the formula of area of a sector of a circle of known radius and central angle of the sector. So if you have not watched the previous my previous videos on area and perimeter of a circle, where I have discussed about the sector, how to find the perimeter and area of a sector, I strongly suggest that you please watch that video. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's start with the part 27 video on the chapter of mensuration, where I will discuss about how to solve how to find the maximum area of grazing by an animal tied with a rope. Okay. Okay, so I have written a few key concepts as notes, as you can see on the left hand side. On the right hand side, I will discuss the concepts. In this video, I will not solve any problem. I will solve problem based on these concepts in some future videos. Okay, so the problem that we will solve is how to find the maximum area over which an animal which is tied at a point with a rope of length L can graze. As you can see on the left hand side, so as I am speaking, please refer the notes on the left hand side. That will in that way it will make more sense to you. So let's say there is a point. Now the point at which an animal is tied, I will refer that point as O. So here is a point O where an animal is tied, let's say with a rope, let's say the rope POB, and so here is the let's say this is the animal. I'm roughly drawing an animal. Now whatever this animal may be, I don't know. So this is the rope, and the length of the rope is small l. So what is the area over which? So what is the concept is, what is the area, what is the maximum area that this animal can cover? As you can understand, it will be let me decrease the size of the rope. Let's say this will be the rope OB. As you can see, the maximum area that the animal can cover will be the circle, will be the area of the circle which is centered at the point O and having a radius of length L. So it will be this circle. Please consider this to be a circle. So this is the area. So the area of the circle is the maximum area over which maximum area that the animal can cover, where the animal is tied to a rope and is tied where the animal is tied at the point O by a rope whose length of the rope is small l. So basically the maximum distance, now the point O is fixed, it will not change. So the maximum distance that the cow can be from the point O is nothing but the length L, and obviously so all the maximum points, all the points which are farthest from the point O that the cow can cover will lie on the circumference of the circle with the radius L. I hope you are getting the idea. So the cow will try to graze along the circumference of this circle, and it can, and the area it can cover is nothing but the area of the circle. Area of the circle. So this is the total area of the circle, is so this is the total area that the cow can graze. Now this will be the total area that the cow can graze if its movement is unrestricted. That is its movement is unrestricted. That is, it can go. It is tied in an area which has no boundary. It can go. That is, its movement is not restricted. But the area will change. The area will vary. It will become different if its movement is restricted. That is, if it is tied inside a rectangular plot, then definitely the cow cannot go beyond the rectangular plot or any closed figure. If the animal is tied inside any closed figure, the closed figure could be a triangle. It could be a triangle. Let's say the cow can be tied over here. This is the point where the cow is tied. Not cow, let's say any animal, and let's say, and the length of the rope is OB. So this is L. The cow can be the animal can be tied here. The animal can be tied at the three vertices of a triangle, or the animal can be tied in a square boundary, or in a rectangular boundary. So in that way, in those cases, the movement of the cow will be restricted, and the maximum area that the animal can graze will not be equal to the area of the circle having radius the length of the rope. So I will consider all those cases separately. So in general, so if the movement of the animal is not restricted, then the maximum area that the animal can cover, or the maximum area the animal can graze if the animal is tied in a grassy plot or in any grassy plot area, the maximum area the animal can graze will be the area of the circle having radius as equal to the length of the rope L. So in that case, the area will be pi L square. We know that the area of a circle having radius r is pi r square. So in this case, the circle will have the radius small l, so the area will be pi L square. So in the unrestricted mode, where the movement of the animal is unrestricted, I mean there is no boundary inside which the movement of the animal is restricted, no boundary, then in that case the maximum area of grazing. Now please note that I am using some notation. The maximum area of grazing, I am denoting it with the letter AG, G for grazing, and we use A for capital letter A for the area. So AG denotes the maximum area of grazing. So in the unrestricted mode, the maximum area of grazing AG will be equal to pi L square, where L is the length of the rope by which the animal is tied. Okay, now let's see some restricted mode. I will consider only two types of restricted mode. That is, when the restricted area where the animal is tied, that area is rectangular or it is a triangle. Okay. Now consider the scenario where the restricted area is a rectangular grassy plot. Let's say the grassy plot rectangular area is OBCD. Now I will always refer the point at which the animal is tied as the point 2. So in the figure on the left hand side, the animal so what happens, the concept is that there is a pole at the base. The better way of explaining is that there is a pole which is standing, which is fixed on the ground, and the foot of the pole is basically the point O, and with this pole there is a rope. The animal is tied. With a rope. Let's say OB is the rope of length L, and this is the animal. So by the point O, I am actually referring to the foot of the pole. Okay. In this restricted inside a certain closed boundary. Now consider the closed boundary to be a rectangle whose length is x and whose width is y. Now, and consider the foot of the pole where the animal is tied is to be the left bottom corner of the vertex of the that is vertex O of the rectangle. Now the rectangle in this figure is OBCD, and at the vertex O the animal is tied, and the length of the rope by which the animal is tied is small l. So you can see OE is equal to OF is equal to L, and the shaded region is the maximum area over which the animal can graze. Now clearly the animal cannot go outside the rectangular boundary, so it has to remain within the boundary of the rectangle. Now, so what is actually the concept of finding if the animal is inside a restricted boundary? Now the boundary could be square, rectangle, triangle, whatever. So what is the actual concept to find the maximum area inside a restricted boundary the animal can graze? So the concept is that let's say, okay, so I am taking the example of the rectangle. Let's say this is the restricted boundary, rectangular boundary, and this is the point O where the animal is tied. Let's say the length of the OE is the rope, this length is L. Now if the movement of the animal where the animal is at the point E, if the movement is unrestricted, then obviously the maximum area the animal could have grazed is the area of the circle with L as the radius, that is, it will be something like this. It will be something like this. Now, and in that case, what will be but now if the movement of the animal is restricted inside the rectangle OA BC, then what will be the maximum area of grazing? It will be this area, that is the area common to the circle centered at O and radius small l and the rectangle. So this would be the maximum area over which the animal could have grazed if where the movement of the animal is restricted within the boundary of the rectangle OCBA. Now how to find the so basically we have to find the area of the shaded region, but mostly all the problems that will be given or you may have to solve will be simple cases. You can easily find the area of the shaded region. So those simple cases I am discussing. So quite obviously, as you can see, if let's say now in this particular case, please note that the length of the rope small l is has to be less than or equal to the both the dimension of the rectangle. That is, the length of the rope has to be, as you can see the shaded region is completely inside the rectangle. This means that the length of the rope L has to be less than equal to x, that is the length of the rectangle. Also the length of the rope has to be less than equal to y, which is the breadth of the rectangle. If the length of the rope becomes greater than any of the length or breadth of the rectangle, then the animal then the shaded region will be completely different. Then the shaded region some part of the area will go outside the rectangle, that I will not discuss. In this particular case, number one, please note that the length of the rope is less than both the length and breadth of the rectangle. In this scenario, the shaded region will be the maximum area over which the animal can graze, and that is nothing but pi l square by 4. Why pi l square by 4? Because as you can see, the shaded region, this shaded region, let's say, so basically we are having this as the corner, So this is the point at which the animal was tied, and we are having, so this is the rope. So if you consider the circle, let me shift this. Okay, now if you consider, so if there was no boundary, the circle, if I draw a circle centered at the O and with OE as the radius, it would be something like this, and definitely the common area between this circle and the rectangle, let's say the rectangle was like this, sorry, this is not a rectangle, but let's say the rectangle is like this. We see the common area, the common region between the circle and the rectangle is this part, and this area, this shaded region will be the maximum area over which the animal can graze, and this area is nothing but a sector which is having a center angle of 90 degree, and this sector is a part this sector is a part of the circle centered at the point O and radius small l, where small l is the length of the rope. So the area of this sector, which is making an angle at the center of the circle 90 degree, is the maximum area over which the animal can graze. And we know that what will be the area of this sector. From the concept of area of a sector, we know that the area of a sector, this area of the sector will be, we know the formula is theta by 360 multiplied by pi r square, where r is the radius of the circle, theta is the angle which the sector is making at the center. Also, please note that one thing is that one term you need to understand is that a central angle. So if there is a circle, let's say this is let's say this be the sector, let's say this be the center of the circle, and we have a sector like this, let's say, and this sector, let's say this is the O, let's say AB. So the sector OAB, the angle, the sector, the angle. Now what is basically a sector? A sector is nothing but an arc. The AB is the arc, and the arc AB is making an angle theta with the center of the circle. This theta is also known as central angle. So this is a term you must be familiar with. Central angle, that so what is the central angle of a sector? It is the angle the sector is making at the center of the circle. So this is also known as central angle. So in this case, we can see the central angle is 90 degree. So we know the area of the shaded region, which is nothing but a sector of the circle of radius small l. The area will be theta by 360 multiplied by pi r square, where theta in this case is 90. So this is 90 by 360 multiplied by pi r square, and which is equal to 90 by 360 is 1 by 4. So this is equal to pi r square by 4. But since in this case the radius r is basically the length of the rope, so it will be actually L, pi L square. So this is a very particular case where the animal is tied at one corner, at any corner of a rectangular field or boundary, and the length of the rope is less than both the length and breadth of the rectangle. In that case, the area, the maximum area that the animal can graze will be pi L square by 4, and you can see the area will be the shaded region as shown on the left hand side, and it will be a sector of a circle of radius L, and that sector is making a is having a central angle of 90 degree. Now any sector, also note that any sector of a circle which makes a 90 degree at the center is known as a quadrant of a circle, or a quarter of a circle. So if for for theta equals to 90, for theta equals to 90 degree, a sector is called a quadrant. Quadrant of the circle, or a quarter of a circle. Quadrant or a quarter of a circle, it is the same thing. Okay, so this was a very special scenario where the animal is tied at one corner of a rectangular plot, where the length of the rope is less than equal to the length of both the length and breadth of the rectangular plot or boundary. Okay, the second scenario is that, let's say the animal is tied at the midpoint of an edge, at the midpoint of the edge AB. So in this case, the animal is tied at the point O, which is the midpoint of the side AB. Now, and the length of the rope is small l, and in this case, the length of the rope L is less than equal to x by 2. So we are having the side AB. So this is the side AB of the rectangular plot or boundary, and the mid and the point and the animal, the foot of the pole by which the animal is tied with the rope, that foot of the pole is the point O, which is the midpoint of the side AB. Okay, so we have basically AO is equal to OB, that is O is the midpoint of AB. Okay, so now let's say the length of the rope is L, the length of the rope is L, and obviously AO and OB will be equal to x by 2, where we have assumed the length of the rectangle is AB, which is equal to x, and the length of the rope, which is L, has to be less than equal to x. L has to be less than equal to x. Also, L has to be less than equal to y. Then what will be the maximum area over which the animal can graze? So as usual, we will draw a circle with the center at the point O. So if and the radius a small l. So this is the circle, and now what is the common region? So let's say this was the rectangle. So what is the common region between the circle and the rectangle? This part. And you will notice that this is nothing but a semicircle. So OE and F. So OE is equal to OF is equal to small l, which is the radius of the circle. So the maximum area that the animal can graze will be the area of the shaded region, which is nothing but a semicircle. We know that the area of a semicircle is half the area of the circle. So in this case, we can say that AG, which is the maximum area, we are denoting the maximum area of grazing with the letter with AG. So AG in this case will be the area of the circle is pi L square, because L is the radius of the circle and the shaded region is the semicircle. So its area will be 2. So its area will be pi L square by 2. So in this scenario where the animal is tied, consider the animal is tied at the midpoint of the the midpoint of the any of the two sides, which is any of the two sides along the sides AB or DC, which is of length x, and the length of the rope L is less than equal to x by 2. Then also the length of the rope has to be less than equal to the y, that is the breadth of the rectangle. Then the maximum area over which the animal can graze will be pi L square by 2. Okay, so this was one scenario. Now the animal, if the animal could have also been tied at the midpoint of the other side, that is side DC. Okay. Now you can also the same scenario can be, now also the animal can also be tied at the midpoint of the sides AD or BC. Let's say we have this rectangle. Let's say the animal is tied. So we have this rectangular boundary or plot ABCD, and let's say O is the midpoint of the side AD where the animal is tied, and also let's say, so this is Y, width of breadth of the rectangular plot is Y and the length was X, and let's say the length of the rope is as usual E. The length of the rope is small l. So what will be, and we need to consider that the length of the rope has to be less than equals to Y by 2, where OD is equal to OA is equal to Y by 2. The length of the rope has to be less than equal to Y by 2, and also the length of the rope has to be less than equal to X. Then if I draw a circle centered at O and radius small l, it will be something like this. Something like this. So so basically this is small l, this is small l, this is small l, this is small l. That is the length of the rope. Now, so what is the common region between the rectangular plot and the circle? This. So this again is a semicircle of the circle of radius small l. So in this scenario also AG will be equal to pi l square by 2. So pi l square by 2, but remember that L has to be less than equal to y by 2, where y by 2, because the animal is tied at the midpoint of the sides either AD or BC whose length is y. Okay. Now the animal could have also been tied on the side BC. It will be the same result. Okay. So this was very special cases about finding the area of maximum grazing where the animal is tied at some point on the sides of a rectangular plot. Now, if the animal is tied somewhere inside, let's say somewhere inside the, if this is so, somewhere inside the rectangular plot, and with the rope of length L, small l, and twice L, if twice L is less than equal to X and twice L is less than equal to Y, then the maximum area on which the animal can graze will be the full circle of radius small l. So this will be, so if the animal is tied at the point O, somewhere inside the rectangular plot, no, sorry, oh yes, somewhere inside the rectangular plot, this is wrong, it will depend. I'm trying to think what should be the position of the point O inside the rectangular plot, so that the maximum area on which the animal can graze will be the full circle of radius small l. Anyway, let's so as you can understand that the maximum area on which the animal can graze will be the full circle of radius small l. If it is tied somewhere inside the rectangular plot, it will depend heavily on where exactly the point O is. If the animal is tied here, then obviously it is highly possible that the full circle some part of the full circle will be outside the rectangular plot. So in that case, it will be hard to find the common region between the circle and the rectangular plot. Anyway, let's forget that scenario. Now the next thing is, if the rectangular boundary is a triangular plot. So a very special case is that, let's say we are having a triangular plot, a grassy plot, where the triangle is an equilateral triangle. Let's say is an equilateral triangle, and let's say the sides of the length of each side of the triangle is x. Okay, and let's say the animal is tied at the vertex O. So let's say the triangle be OBC. So I will always refer O as the point where the animal is tied. So let's say at the point vertex O of the triangular plot, animal is tied, and let's say the animal is the length of the rope is small l, as usual, small l. Then the maximum area over which the animal can graze will be this sector. Let's say this be E, this be F. So obviously in that case, and we know that this angle is 60 degree, because each angle of an equilateral triangle is 60 degree. So in this case scenario, so the maximum area, as you can see, the animal can graze will be the sector OEF, which is making an angle 60 degree at the center of a circle of radius small l. Okay, so we will have OE is equal to OF is equal to the length of the rope, and if you consider this sector, so OEF is a sector of circle of radius L and a central angle, that is the angle it makes at the center of the circle, central angle of theta equals to 60 degree. So what will be the area of this sector? This sector is having a central angle of 60 degree, and it is a sector of a circle of radius L. So AG in this case will be 60 by 360 multiplied by pi L square. 60 by 160, 60 by 360 is 6. So the area will be pi L square by 6. So this will be the maximum area over which the animal can graze if the animal is tied at any vertex of an equilateral triangle, at any vertex of an equilateral at any vertex of a triangular plot which is an equilateral triangle, and the animal is but one thing we must note, that the length of the rope L must be less than equal to x. Mm, no. Uh, uh, no. If the length of the rope is x, if the length of the rope is x, then obviously uh, the sector will be something. The sector will be something like this, and the maximum area will definitely be the entire triangular plot. That is the area of the triangle. Okay. Now, uh, I think this formula that the area, the maximum area, if the animal is tied at the point O, then the maximum area of grazing will be pi L squared by 6. This will basically depend on L. Now, depending on how what is the value of L, depending on L and the X, depending on L and X, this shaded region, this sector may some part of it may be outside the triangle. Let me see. So if this is the arc, this is the arc. If I draw a perpendicular from the vertex O on the side BC, then this let's say the perpendicular is intersecting the arc EF at the point G, then OG will also be small l. OG will also be small l. And so I'm just wondering what could be the maximum value of L such that this entire sector will lie inside the triangle. Now that maximum L, the length of the rope L will be such that that maximum length will be the length of the perpendicular O. Let's say this point is H. OH is the, so we know what is the height of a formula. So OH, we know that what is the height of a of an equatorial triangle of side length x, the area of an equatorial triangle of side length is 3√3 by 4 x square. We also know that the area of a triangle is half multiplied by base. The base is x, and if I consider the height as h, this should be equal to √3 by 4 x square. So this implies the height of an equilateral triangle. I'm just trying to find out. I forgot 2. So this is √3 by 2x. Okay, √3 by 2x is the height. So the maximum length of the rope, that is small l, in terms of the length of the equatorial triangle, will be such that will be equal to the height of this equatorial triangle. So basically, when the length of the rope is equal to the height of this equatorial triangle, which is OH, which is equal to √3 by 2x, then the scenario will be like this. And that is it will the sector so let's say this be I and this be J. So the sector will now be OIJ, and which will and the arc IJ will barely touch the side BC at the point H, and so in that case, L will be equal to root 3 by 2 x. So a question could be asked that in this scenario, that there is an equilateral triangle of side length x, and an animal is tied at one vertex, let's say O, and you are asked what will be the length of the rope such that it will such that the area over which the animal can graze will be inside the triangle, maximum area. Then the length of the rope should be root 3 by 2 x. Anyway, so as long as we can see that as long as the length of the rope is less than or equal to root 3 by 2, so in this scenario, I should say that if length of the rope is less than or equal to root 3 by 2 into x, where x is the length of the where x is the length of the side of this equilateral triangle, as long as L, small l, that is the length of the rope, is less than or equal to root 3 by 2 x, the area, the sector will be inside the sector will be inside the triangle, and the area of the sector obviously will be pi L square by 6. Pi L square by 6. Okay. Next let's see. Let's see if so. This was the case where the plot was triangular plot, and the triangle was an equilateral triangle. Now, what if the triangular plot, it is not an equilateral triangle, it is some scalene triangle, that is all the angles are different. So in the note on the left hand side, you can see we are having, let's say, a triangular plot. I have referred all the vertices with O, since I am considering O to be, I am naming the point at which the animal is tied with the point O. So this is O1, O2, this is O1, and this is O3. Let's say these are the vertices of any triangle where the angle O, this angle is theta 2. Let's say this angle of the triangle is theta 1, and this theta 1, theta, all these angles are in degrees, and let's say this be theta 3. Now let's say the animal is tied at the point at the vertex O2, and the length of the as usual, the length of the rope is small l. So this is L, E. The animal is at the point E. Then what will be the maximum area over which the animal can graze? So it will be the sector, this sector. So let's say this point be F. So we must have O2 E is equal to O2F will be equal to the length of the rope. And what will be the area of the sector which is making? So this is making a sector. So this is a sector having a central angle of theta 2 of a circle of radius small l. So if I consider this, when the animal is tied at the vertex O2, let's say the maximum area over which it can graze, the animal can graze, be AG, let's say AG2. On the note, in the notes on the left hand side, I have referred that to be AG theta 1. G theta 1, AG theta 1 means the maximum area the animal can graze when it is tied at the vertex O2, and where the angle at the vertex O2 of the triangle is, sorry, so this thing, let me clarify. So the maximum area over which the maximum area of grazing of the animal when it is tied at the vertex O2, where the angle of the triangle at vertex O2 is theta 2, I am referring that maximum area to be A G theta 2. I hope it is clear. Now please don't be worried about all these complex notation. This is just for the sake of discussion. So this will be equal to the area of the sector, of a circle. The circle will obviously have the radius small l, that is the length of the rope, but the sector is having a central angle of theta 2. So this will be theta 2 divided by 360 multiplied by pi l square. Now certainly this will be the area. Certainly the L has to be less than let's say the length of the sides of the triangle B, this be x and this be y and this be z. That is, let O1 O3 be equal to x, O2 O3 be equal to y, and O1 O2 be equal to z. Now even the animal is tied at the vertex O2, the length of the rope small l definitely has to be less than z. Then only the maximum area over which the animal can graze will lie entirely in will be the sector will be inside the triangle. Now what will be what will be the maximum length of L such that this sector lies inside the sector will completely lie inside the triangle? I'm not sure of that, but I'm not sure of that. I don't know. So similarly, when the animal is tied at the point at the vertex O1, so the maximum area on which the animal can graze will be this sector. Let's say this be E, F, G, and this point be H. So definitely O1G will be equal to O1H will be equal to the length of the rope or the radius of the sector, and then the maximum area of the sector when the animal is tied at the point at the vertex O1, where the angle is theta 1, that will be AG theta 1 will be equal to theta 1 by 360 multiplied by pi L square. So as you can understand, similarly we will have when the animal is tied at the point at the vertex O3, AG theta 3 will be equal to theta 3 by 360 multiplied by pi L square. Now okay, so let this be I, J, so this is L, also this will be L. Okay, so this was some idea about the maximum area of grazing when an animal is tied with a rope inside a boundary. That boundary could be rectangular or triangular, or it could be any other figure like square. I hope this will give you some idea of how to find the maximum area of grazing when an animal is tied with a rope of certain length, let's say inside a restricted boundary, especially at the corners of some rectangular plot, or at the corners of some triangular plot. I will come up with some example problems based on this concept in some future video. Once I complete solving the problems of the exercise 20G and the test paper, then I will solve some problems based on these concepts. Now, before moving on to solving the problems of the next exercise, which is 20G, which is objective questions. They are objective questions based on the entire chapter of mensuration. I would like to solve a few example problems based on how to find the area of shaded region based on circles. That is, when some circles are drawn inside, one or more circles are drawn inside a square or a rectangle, then we have to find certain shaded region. I would like to solve some of those problems to give you good practice and idea. Okay, so I hope this video will be beneficial to you. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.